Hey everybody, I guess I'll start, it's 1 minute late. That's okay. Okay, great. So I'm going to talk about runtime agents, but generally speaking, I'm going to talk about an event-sourced model for doing collaboration. And just the kind of quick intro part, I'm Kelley, I'm RGB KRK on GitHub. I've been an IPython and Jupyter developer since about 2012. I'm a principal engineer at Anaconda. I realized I should have grabbed water right before. Maybe I'll get some water in between some things. And just as an aside, just to kind of intro things, I mean, I've worked on a lot of pieces of Jupyter, but some of the stuff that I've done more recently that I'm not going to talk about today, except for this one slide, is that I wrote Rust bindings for Jupyter. And that same Rust library, which is called Runtime lib, as well as MB format, a bunch of crates that are all for the Jupyter protocols, gets used by Zed. Here, I'll play a little thing. So it lets you run code inline inside the Zed editor, and then is the same Rust code that's used for the Dino TypeScript kernel. So thank you so much, Jack. Great. And so I've been away from the project for a little bit. Some of the stuff that I've been working on has not been about Jupyter. I've gotten involved in politics at a local level, serving on the Santa Cruz City Schools Board. And it's taught me a lot about kind of long-running projects that are going to have a lot of different stakeholders. I just realized I don't need that slide anymore. And so we've been working on this educator housing project for Santa Cruz City Schools. And the main thing that we're aiming for, Santa Cruz is extremely expensive to live in, so we wanted to build 100 homes for educator families. And we'll be breaking ground on this in just a few months. And you know, like the reason you do these things is that it's not the building, it's not the actual project that you're working on, everything that's kind of get the thing done, right? It's about the purpose and intent is for the people. Like what it is, why are we doing it? We want to recruit and retain teachers and everything else. And I think going through this process and knowing like this is our North Star, this is why we're doing this, helps you align for what your engineering objectives are. That's my trying to like tie this back together. And you get to see, you have to make decisions. A lot of times in these groups, whether you're working with educators and architects and community groups, everybody wants to have some involvement, and there's a lot of consensus building. And sometimes you just have to say, we're doing it this way. Here's what we do. And so back to that, like in pursuit of people, as opposed to just like engineering problems or things we want to solve, is that I used to run the notebook platform at Netflix, and a big problem would be that people would try to run code, and they'd be working in their notebook or whatever. End of the day, maybe they were running a Spark job, running Hive, or they're training a model, and it didn't finish yet. They would be walking to their laptops with the laptop held open, hoping that the results would come in, and it would get pushed into the notebook so that they could close their laptop and go pick up their kids from school or go to soccer practice or whatever it is. And I was like, God, this sucks. This is a work-life balance problem because we never solved this in Jupyter. And so we patched some things that Min put in something to repeat messages when you'd reconnect, but it wouldn't always work over a VPN. There'd be all these different issues, and we were just kind of patching over the problem in some sense. And so I think a lot of people already know this, but I'll walk through it pretty quick, right? The Jupyter model for how your notebook works, right, is you've got a front end, Jupyter server, and a kernel. And as you're making edits to the notebook, you're creating this notebook state in memory. And as you want to send, you're going to execute some code, you send this execution request over, and the kernel responds with outputs. This is all happening over WebSockets on the front end of Jupyter server side, and then 0MQ from kernel to Jupyter server. And then you take that output and you put it in the notebook state, And it's not until you've clicked save or it's auto-saved in some way that you serialize the notebook into what goes on disk. And at any given moment, if you've been making changes, what you have in your browser is not necessarily the same as what's saved on disk. And so there's this kind of ephemeral storage model that's just always been happening. And I think in general, like this is kind of okay for localhost. There's areas where it breaks down on localhost, but especially isn't good for remotes, right? Because you don't know if you're self-finished. If you had any sort of connection loss of any kind, you won't know, did it error? Am I still on the same kernel, or did I have an out-of-memory error? Maybe you had loaded a whole bunch of data. You have no idea you blew up the kernel. And then, especially on the local version, you don't know if maybe you have it open in another instance or another tab, right? And so this is just kind of setting the stage for this kind of bad user experience we've been dealing with. And so the big shift in our case is that we need to have server-side documents as a source of truth. And there's a lot of options for this in Jupyter right now. So there's the Jupyter collaboration, there's Jupiverse, which is basically Jupyter collaboration, but with fast API server underneath it, and Jupyter server documents. And underpinning all of those is the PyCRDT libraries, so that's conflict-free replicated data types. And so that allows basically patches of changes that are gonna go against a document. All clients are able to communicate those. And I think in many cases they get terms as real-time collaboration, but for me, the thing I care about is the fact that I have a server-side model of that notebook. And so there's some relevant related talks to what I'm talking about now, specifically about the CRDT. If any of you brought a time machine, after this talk is over, please use it and go back to yesterday. It was a great talk from Zach and Abigail. But if not, there's another talk later with Siobhan and Zach at 2:20 in the island room. And so the differences between each of these, because these are each their own Jupyter extension, is there's some differences in thinking about application state, the documents, the outputs, the APIs. And so we have to figure out how we're gonna rectify it. Like what is it that we're gonna mainline and bring in? And obviously if there's multiple competing standards, the next thing you should do is create another competing standard. So that's why I'm gonna talk about event sourcing. And it's probably more familiar than you expect if you've done JavaScript work and you've worked with Redux. So do I show it first? I'm gonna come back to my demo. Actually, no, we'll demo first. Okay, so the main thing I'm gonna show is this event log. But the main thing, let's see, is this working? Let's change some stuff. Maybe we'll make this bigger. Okay, great. So let's solve that first problem. So I'm gonna have a long running thing here. See if I can set this down and then run stuff. Maybe, maybe not. All right, so I'm gonna run this cell. And that's gonna take like 10 seconds. So I'm gonna close it. I don't know if everybody saw me run it real quick there. And then now I'll open that notebook again, and we get our final result. I didn't have to stay connected. Kernel had submitted document updates. It goes into the notebook. I don't, I didn't lose anything. Like I just came, I got the updated events, and then we go from there. And so I'm gonna show you under the covers what this looks like, and then I'll walk through what it is and why. So when I started this notebook, this is probably the thing I need to make bigger. Every single action that I took within the notebook that was state that I wanted persisted for all users is an event in this event log. And so like if I created a cell, if I changed metadata, I clear the outputs, I request execution. Each of those is a transaction that happens and is this overall ordering. And then like that alone isn't useful like solo. What I really care about is the derived data. So this is like, I have an event log that is all in SQLite, that's my data table. And then I create a derived data version I create new tables that are derived from the original event log to create what are the current cells, what's the source code for those cells, which this viewer doesn't show it very well in here, but there's more text in there. Oh, this is looking at a different notebook. Let's look at this notebook. Okay, yeah, this notebook has like 11 cells. It's got markdown cells and code cells and AI cells, but I'll touch that again in a second. And then I've got this execution queue that's tracked every single execution that happened, and then who requested that execution, what was the client ID, because it could be different users, but the same, they could be in different tabs. But basically, I have like a full audit trail of everything every user did within this notebook. And I can see, I have a clean state for everywhere. And the thing that's running against this over here is this is the runtime agent. So it's running a kernel underneath and also has its own copy of the document and will submit changes to the document in response. So technically, it could be writing cells as well, which we'll be able to see with the AI cells. And heck, I might as well delete some of those. So that's kind of at a high level the way the event log works. So I'm gonna go back to slides. Yeah, so like I was saying, so core concept here, every change is an event in that persistent log. Every event is immutable. Oops, I can use this. And then we can rebuild state by replaying events. So that is, if I want to know what it was at time t, I basically have this time travel just by virtue of this being a sequence of events. And then every user and agent's actions are attributed in that log, whether that's the kernel doing it or you have some automated process doing it, you had a scheduled job, or you connected in some strange new way. And here I'm just showing the same thing that I decided to show live instead. So in practice for notebooks, that means that the events are things like cell created, execution requested, we get terminal output, maybe there's markdown output that's appended. And instead of relying on dealing with merge conflicts, we rely on event ordering. That is, we can't insert a new event until we know that you've already pulled all the new events. You have your own local copy that you're applying events to, and you're pushing those events out as best you can. And I'll show a diagram to help see what that looks like. And I want to point this out because as we're kind of on the precipice of pushing forward in collaboration, I wanted to be able to show the Jupyter community what this looks like from how CoCalc operated, how Notable operated for how it did deltas, though this is far removed from that, nothing shared. Notable was not open source. And then Interact and Redux also operated on a similar fashion, but it was never hooked up to be real time. So like I was saying before, basically we commit events, we materialize those events into a database that we can query from on the front end. So there's, we can say select ID from cells where maybe let's say that where the cell type is markdown, right? Get all the markdown cells. So it's basically like your whole notebook is queryable on the front end, and that's made it really easy to do front end development on top of it, which is kind of an aside from anything about the model. It's more just like for ease of querying, I'm enjoying it more than some of the other front end state libraries. So back to this like event log thing. How does this piece work? So we've got two clients here. We've got client A and client B, and we've got our sync backend. And so client A and client B and the sync backend all recognize the current, we'll say it like head, like of a Git repository is E2 right now. And client A is gonna add event E3. And so it's gonna push it to the sync backend. And when it does that, it finds out, oh, okay, so I was up to date. And so everybody gets to pull the changes based on that. Like they get to pull all events that they might be missing. So only client B is missing event E3. So it gets that E3 back, it's got the new event, and then that's how they all become synchronized on it. And so I think the core concept behind this for trying to make this work, it isn't just about the event sourcing model. So this event source model is coming from a group of local first developers. That is, they're trying to build apps that'll work on your machine even if you're disconnected. That is, you can have all the events in your browser, and then once you connect, you get to push those events out. But in our case, we actually want a kernel that connects as a client as well. And so instead of, as it is like right now in mainline, is that the user and kernel don't, they connect to each other. And in this kind of setup, instead they connect to a document. They connect to a document engine, and they bring it together. And it does mean that anytime you want to do something on the document, all clients should know the state of the whole document. Like when we execute, we don't say, I want you to execute this code. It's, I want you to execute this cell by ID with the knowledge, basically, implicitly, that you know that cell at that time had those cell contents and could be run, right? And so this runtime agent is an independent process. It reads the events, executes code, and writes the results. And so like once you have this, and this is irrespective of what that storage model is underneath, is that if you have server-side models and runtimes that act as clients, that opens up opportunity. I think the big one, and this is why on some level I was like, oh, maybe I won't talk too much about the AI part of this, even though it's very essential to it, but it opens up opportunity. So you can have a scheduled notebook that runs in the background that you fire off, and once it's ready, maybe you knew you were gonna pull up a bunch of data, or you knew you were gonna work with it in the morning or whatever, and it was an expensive machine, is that you're gonna attach once it's ready. That is, it can run and do its own thing, and then you attach later on. I think of this in Netflix terms, there were times where you'd want to query 3 hours worth. And it might be that you would just stage data, you'd put it, you'd create a Parquet file off of the stuff and then go at it later. You'd create some process, but sure would be nice if I could just attach to a notebook once my data is loaded and ready, and then I can work with it right there. And on the same level, because I have this model, it means I can bring AI in the loop. It means that I can have different clients that I'll authenticate to the same system and allow me, so if I pull up my phone, I can edit this same document from multiple spots. And I guess maybe it's worth it for the next part of this demo, not this one. Here we go. So I'm gonna open up. I feel like I have to show it, otherwise it's I don't believe you. Does it really work? So this is two different users. This is White Rabbit, and this is Gray Rabbit. And they're gonna both be using the same kernel, so I'm just gonna run this cell again, right? So before and after. Two totally separate Chrome profiles. They're not sharing across a tab or anything. And they've got totally shared state on what's there. This does not handle diff match patch though, so I only submit an update to the cell once you've blurred it. So that's that piece. And I guess as a treat, I'm gonna delete a bunch of cells. Actually, I'll do it here, and then maybe, let's see, what do we have? I don't want this code. So I'll delete cells on this side too. That way the audit log has it for both people. Okay, great. And then now, I'm gonna say, show me how to use Seaborn. Okay, so both users get to, so I've created this AI cell. And the AI cell, it doesn't really have to be in a cell, it could be anywhere, but I was something that Jeremy Howard was showing me was how he would use AI inline in a cell. And I was like, oh, maybe we should just do that instead of trying to have it as a separate panel. What does it look like? What's the UX like? I think there's some weirdness here. Oh, this is funny. It didn't call any tools. I'll be explicit. All right, let's run that again. Okay, so model can create tool. Oh, look, it had trouble with the code it ran. Oh, that makes sense. Oh no, I'm gonna have to tell it to use PyFetch. Oh, look at that. Okay, now it figured it out. It debugged it. So what's happening in here, if anybody doesn't know about the AI piece here, is the AI is given these tool calls. So it's given access to create cell, and it's given access to a tool called execute cell. These are pretty basic. It's similar to what we did for Notable's ChatGPT plugin. And it's able to work inline in the notebook. And I think, there's probably there's some UX to be studied about how do you make this feel natural that you're really pairing within it. But yeah, this is an area where it can see all of the outputs in the notebook, so it sees everything that we wrote above. So I think maybe as an alternative, I said switch up the above progress bar to have a total of 30. It's like a silly eval because I know what the right result should be, and we'll see if it does it. And so it modified this cell, and it made the total 30, and it ran it. And all this AI stuff, it's happening server side. It's not running in the browser. It's just me looking at a document that's shared between them all. Yeah, get some water for a second. Cool. So all of this is open source. It's in the Runtime org, which has all the Rust libraries as well. But it's in something called In the Loop. And I will show that on the screen at least. Runtime/in the loop. And there's way more detail in the README in there about how it works, how to work with it, and kind of where we're taking it. I would show you a different live demo and have everybody do it, but the conference Wi-Fi has been terrible, so I scrapped that entire demo and was like, I'm going to make this work all local with local models and everything else. So everything I was showing was running just on my laptop with a locally hosted model. I was using the GPT OSS model. Yeah. Any questions? Yes, in the back. Yeah, so the question was, are there any guardrails around if you have a collaborator that changes a variable, or maybe they do something either disastrous on purpose or disastrous on accident? So right now with the system that we're working on, I think this even applies for some of the CRDT work, is that it's basically on or off. You've given somebody permission to work on the document, and so they can do anything. And I view that right now as a personal coordination problem, but I do want to have explicit controls over which actions can be performed. So when we get that event log, we should just reject that event. Say, oh, well, this person is not able to execute, or this person can't change those cells, or whatever. Right now, that's not built in. It's basically you're in or you're out per notebook. And so I didn't show me sharing this notebook with myself with this other profile, but that's how that one works.
So with Paradise, the models you're running on your laptop, including your notebook server, everything here in the notebook is just in that machine right now.
Yeah.
Are the tool calls, you're generating code or markdown in there, but so are the tool calls put the generated code in the cell, execute cell? Why did you decide to use tool calls for the?
So the question is, and I guess I can repeat the previous question. The previous question was so are you running all of this locally, including the runtime? And the answer on this is yes. And actually, this server-side runtime that I'm using is actually in Pyodide. I wanted to have some sandboxing, so I was just happily throwing things into Pyodide, even on the server. So it's kind of weird. I've taken WASM all the way back to the server to do the runtime piece. And then the other question. Oh no, now I've spaced. Go ahead, repeat. Oh, for tool calling, right.
Are they, did you just do like, put it in code, go to the cell, execute code, and what was your,
Yeah, let's, oop. Oh no, I just killed the server while we were doing that. That's okay. Actually, what's really fun about killing the server is that the runtime is still up. I think it's true. If I reload this still, I'm just, because I had to see, is it, oh, X is 2. I never ran that cell, so X was something else over there. Oh, I didn't add it. No, X. Oh wow, I can't read code. Here, I'm gonna pull up. Let's. Oops. Create cell. Cool. Okay, so we have this tool registry, and so we're using generally the spec that OpenAI came up with for you provide an open API schema for your parameters. I'm really happy with OpenAPI for things like fast API and everything else. And it does mean that you're effectively prompting by putting in descriptions for your tool calls. And so like with this runtime agent, and the runtime agent doesn't have to operate in this fashion. It can always, you could have your own separate tool calls that do create cell or whatever else in a different way. But I bake these ones in because it helps show like what it is. I want to have 1 minute. That means I'll show one last thing then. I'm going to import random just to show. So we can register a tool call. I'm going to say roll die, and then we're going to return random dot rand int 1 to 6. I could give it parameters. Maybe I'll do that. So, well, yep, live demo went bad. Oh, I know what went wrong. I'm surprised it didn't show that. Roll a die. And then if I go to AI, we use that same model, and I say, oops. Roll a die. So it's going to generate the tool call for it. Because it's like a brand new tool, I made it so at least there's guardrails on whether or not you can let things run. Because we also hook this up to MCP. So I'm going to click always allow. And then I accidentally hid that. Yeah. Oh, I know why that's not showing anything. I killed multiple servers. Let's reload this page. Yeah, all right, I'll leave that. Because I killed servers that died a bit. Thank you all again so much.